Water in space doesn't fall, drip, or splash, it floats. It clings together in perfect shimmering spheres, defying everything we expect from liquid. But have you ever wondered what it feels like to drink from a floating water blob? Or how playing with water in microgravity could change the future of space travel? Today, we're diving into the mind-blowing reality of water in space, a world where the simplest drop becomes a science experiment, a toy, and a tool for discovery. Aboard the International Space Station, water behaves like it's in a sci-fi movie. No spills, no puddles, just perfect floating blobs drifting like tiny transparent planets. Without gravity to pull it down, water sticks to itself, forming shimmering spheres that hover in midair, practically begging to be played with. And trust me, astronauts love playing with them. They release tiny droplets, merge them into bigger ones, poke them, stretch them. It's like an intergalactic water balloon fight, but in slow motion. One of the most striking aspects of water in space is the way it clings together, forming nearly perfect spheres. On Earth, when you pour water from a bottle, gravity pulls it downward, causing it to spread, splash, and soak into surfaces. But in microgravity, surface tension takes over. This force causes water molecules to cling to each other, forming droplets instead of dispersing into a mist. With no stronger force pulling them in any particular direction, these droplets grow into floating blobs, maintaining their shape like suspended liquid marbles. Astronauts aboard the ISS take full advantage of these peculiar properties, engaging in experiments that are equal parts science and fun. Some of the most famous videos from the ISS show astronauts releasing tiny droplets of water, watching them drift freely, and then combining them into larger globs. A simple touch from a finger or tool can reshape the blob, sometimes breaking it into smaller droplets or merging it back together. The ability to manipulate water in such an unrestrained manner has been mesmerizing not only for astronauts but also for people watching from Earth. Drinking water in space presents an interesting challenge. Without gravity to pull liquid to the bottom of a cup, traditional drinking methods become impractical. Instead, astronauts rely on specially designed pouches with built-in straws to keep hydration easy and mess-free. However, in the spirit of curiosity, astronauts have also tried drinking directly from free-floating water blobs. They can guide a glob of water toward their mouth and slurp it up. An act that looks almost comical, but works surprisingly well thanks to the cohesive properties of water. The surface tension holds the liquid together long enough for them to drink without making a mess, at least most of the time. Water blobs provide endless opportunities for experimentation, and astronauts have explored numerous ways to manipulate them. Injecting air into a floating blob creates mesmerizing effects, as tiny air bubbles become trapped inside, sometimes forming intricate patterns as they dance around. If food coloring is introduced, it disperses in slow, swirling motions, creating a hypnotic visual effect unlike anything seen on Earth. Adding different substances to a water blob, such as oil or effervescent tablets, leads to even more fascinating reactions, with oil forming distinct layers and fizzing tablets, creating tiny, chaotic bubbles that push the liquid in unexpected directions. The largest water blob ever created on the ISS was the result of an experiment by NASA astronaut Scott Kelly. He and his team used a special hydrophobic camera to film an enormous floating sphere of water, allowing them to study its behavior in incredible detail. This experiment wasn't just for fun. Scientists on Earth closely analyzed the footage to understand how water behaves in microgravity, offering insights that could be applied to future space missions and even fluid systems in spacecraft. Beyond its entertainment value, the study of floating water blobs has serious scientific implications. Understanding how liquids behave in space is crucial for designing more efficient fuel systems, better life support systems, and improved methods for recycling water on long-duration space missions. The way water clings to surfaces and interacts with different materials helps engineers create better spacecraft components, ensuring that water and other fluids can be stored and transported safely in environments where gravity is not available to guide their movement. One of the coolest water experiments performed on the ISS involved using water to create a makeshift lens. Astronauts carefully shaped a large blob of water and placed a small camera behind it. The refraction of light through the spherical liquid formed a crude yet effective magnifying glass, proving that in microgravity, even something as simple as a drop of water can take on new and unexpected functions. This experiment showcased the potential for using floating liquids as optical tools, a concept that could one day play a role in space-based imaging or scientific instrumentation. Perhaps the most captivating aspect of watching astronauts play with water blobs is the sense of wonder it evokes. While these experiments have real scientific value, They also serve as a reminder of the sheer joy of discovery. Seeing an astronaut gently push a floating sphere of water with their fingertip, watching it vibrate and change shape in slow motion, is a powerful demonstration of the extraordinary nature of life in space. These moments of playful exploration not only educate but also inspire, offering a glimpse into the boundless possibilities that microgravity presents. The ability to manipulate and study water in space extends beyond scientific curiosity. It plays a crucial role in future exploration efforts. As humanity prepares for longer missions to the Moon, Mars, and beyond, understanding how liquids behave in microgravity environments will be essential for survival. Water recycling, fluid dynamics in closed-loop systems, and even potential ways to grow food in space all depend on the fundamental principles demonstrated by these seemingly simple water blob experiments. Through these floating spheres of water, astronauts experience both the joy of play and the thrill of scientific discovery. Whether using them to demonstrate physics, conduct experiments, or simply take a sip in an unusual way, water blobs are an iconic and endlessly fascinating part of life aboard the ISS. They represent the strange and wonderful realities of microgravity, where even the most familiar substances can behave in ways that defy our everyday expectations. I'll leave you to discuss in the comments. If you had the chance, what weird experiment would you try with water in space? You can support us by subscribing if you haven't already. Take care of yourselves, take care of your loved ones, and I'll catch you soon in another video.